Hi everyone, today's question is from the chapter Current Electricity. It's quite a good question, so let's see what the question says. A cylindrical conductor has length L and area of cross section A. Its conductivity changes with distance x from one of its ends as sigma equal to sigma naught L by x, where sigma naught is a constant. Now this means the conductivity sigma changes as you move along the rod, which means if conductivity changes, remember resistivity also changes. Calculate the electric field inside the conductor as a function of x when a cell of EMF capital V is connected across the ends of the conductor. So here is the conductor whose area of cross section is A and length is L, and a battery of EMF E equal to V is connected across the conductor. I will assume the internal resistance of the battery is 0. Now because of this cell, current will flow, right? And please remember, whenever current flows in a conductor and they will ask you to find electric field inside the conductor, always think of using vector form of Ohm's law, which says J equal to sigma E, right? So sigma conductivity is given, E we have to find. So we need to find J. Now what is J? Current density, whose formula is current per unit area, isn't it? To find J, I need to find current. And since they have given the potential difference V, current can be written as V by R. So the only thing we need to do is calculate the resistance of this conductor. Now, can I use this formula to calculate the resistance? The answer is no. We cannot use this formula because as I move along the length of the rod, as this L is changing from 0 to L, this resistivity is not constant. Right? This formula can only be used if this resistivity is constant. But as you move along the rod, the resistivity is changing because conductivity is changing, right? So since we cannot use the formula rho L by A directly, what we need to do is consider a small section of this rod, which will be like a disc, right? And this disc you consider at a distance x from one end of the rod, and this thickness of the disc will be obviously dx, right? If this is x, small change in x will be dx, isn't it? So we can write the resistance of this small portion of the rod as dr equal to, now here whatever resistivity is there, let us call it rho. Remember the resistivity is changing. So I need to use resistivity at this location, which is at a distance x, remember. So rho at the location of x into length of this section. The length of this section is dx, right? Divided by area. Well, area is constant, so we can directly write A. Now what is resistivity at this location? Well, they have given you conductivity at x. So resistivity at x will be reciprocal of conductivity, isn't it? So resistivity will be x by sigma naught L. So your dr will be equal to x by sigma naught L dx by A. Now if you consider this, all these sections, this one, this one, this one, all of them are in series. So if this dr is resistance of one of them, the total resistance will be just summation of all the individual resistances. Why? Because all these individual sections are in series. So the total resistance will be integral of dr. Then we can take the constants outside, sigma naught La, and integrate x dx. Now as you go from this section to this section, your x will go from 0 to L, right? And this integration is obviously very easy to do, right? Integral x dx is x square by 2. Put upper limit and lower limit, you will get L square by 2. So the final resistance will be L square by 2 divided by sigma naught La. One L will cancel, so it will be L by 2 sigma naught A. So that's the resistance of the conductor. So once I know the resistance of the conductor, the current can be found by using Ohm's law, V by R. So V is constant, R is L, and this 2 sigma naught A will go up, right? Then if you bring this A this side, I by A will be J, right? So 2V sigma naught by L. And then we can use the formula J equal to sigma E to find the electric field, which will be J by sigma. Now J is 2V sigma naught by L. Sigma itself was sigma naught L by X. So sigma naught gets cancelled. So finally your E will be 2V, X will go in numerator, by L square. So this would be the electric field at a distance x from one end of the rod, right? Now in exam they may not ask you the expression of electric field. They may give you 4 graphs of electric field versus this distance, and you have to choose the right one. Well, according to this equation you can see, since these are constants, E and X are directly proportional. That means if you plot a graph of E versus X, it would look like a straight line, right?